Hey everybody, Chris Kresser here. Welcome to another episode of Revolution Health Radio. Today we have a question from Kelsey. Let's give it a listen. This episode of Revolution Health Radio is brought to you by 144.me. 144 is a diet and lifestyle reset program I created to help you dial in the 4 pillars of health: nutrition, physical activity, sleep, and stress management. Whether you want to lose weight, boost your energy, treat a chronic health problem, or just maintain your current good health and extend your lifespan, these are the 4 areas you need to focus on before anything else. In the 144 program, I walk you through every step of the process, from cleaning out your pantry and shopping for the right foods, to recipe and meal plans, to video demos of workouts that you can do at home without any special equipment, to guided meditation and stress management programs, to daily sleep tips, to personalized recommendations for what to do after you finish the reset. 144 is a great option whether you're just getting started with this stuff or you've been on the path for a while. In fact, I do a 144 myself 3 or 4 times a year to hit the reset button and give myself a boost. To learn more about how 144 can help you achieve your health goals, head over to 144.me. Okay, now back to the show.
Hi, Chris. I was just wondering about your thoughts on the ketogenic diet as an approach to cancer prevention and therapy. I just read something about how cancer cells can only thrive on glucose, and in its absence, we can prevent cancer potentially. So I was wondering if you could discuss this in a podcast. I think that would be great. Thank you.
Okay, thanks, Kelsey, for sending that question in. It's a really great question, one that's been on my mind a lot recently, actually, and I've been diving into the research on. Now, most of you probably know that cancer dogma holds that malignancies are caused by DNA mutations inside the nuclei of cells, and these mutations ultimately lead to runaway cellular proliferation, which is the hallmark feature of cancer. But there are some cancer biologists out there that feel that while mutations are ubiquitous in cancer, they may not be the primary driving force of the disease. And as we'll discuss later, they may actually be secondary effects of a deeper underlying process or another underlying process. And they believe that cancer is as much a disorder of altered energy metabolism or energy production as it is genetic damage. And this goes back to the work of German physician Otto Warburg in the 1920s and 1930s. And we know that healthy cells generate energy using an oxygen-based process of respiration. So this is what we refer to as cellular respiration. But Warburg was the first to note that cancer cells prefer anaerobic or oxygen-free process of producing cellular energy known as fermentation. And contemporary researchers like Dr. Thomas Seyfried and Dominic D'Agostino have argued that this dysregulated cellular energy production or cellular metabolism is actually what induces malignancy, and that by extension, if we limit the fuels available for this process of fermentation, and the fuels are glucose that's derived from carbohydrate in the diet and glutamine that's derived from protein in the diet, then we can actually starve cancer cells and either improve the results of conventional treatment or perhaps even address some cancers independently without conventional treatment. Now, in this view, it's the mitochondria that are particularly to blame for cancer. And there are studies in the 70s and 80s that support this. They showed that if you transfer the cytoplasm, which is where the mitochondria is, from a healthy cell into a cell that has the potential to develop cancer, that potential is suppressed, or that tendency to develop cancer is suppressed in that cell. On the other hand, if you transfer the nucleus of a malignant cell into the cytoplasm, which again is where the mitochondria is, of a healthy cell, then the tumor potential of that initially malignant cell is inhibited. So both of these lines of evidence suggest that the issue may be with the mitochondria or the cytoplasm of the cell rather than the cell nucleus, which is what the traditional view of cancer is. So Seyfried agrees that there is clear evidence that cancer is a genetic disease since we can inherit mutations that are clearly associated with increased cancer risk. That's not at all controversial. That's well established, and even Seyfried agrees with that. But he argues that many of these mutations that we can inherit are mutations that actually disturb cellular respiration. So maybe the heritable aspect of cancer is not, a mutation that drives itself cellular proliferation, but instead are mutations that actually cause mitochondrial dysfunction and defects in cellular respiration. He also points out that many of the non-inherited causes of cancer that have been identified and are clearly recognized, like radiation, impair mitochondrial function. So that may be a common mechanism that's shared between these non-inherited causes of cancer and inherited causes of cancer. Mitochondrial dysfunction can be caused by any number of different carcinogens, genetic predisposition, but also radiation, chemical exposures, and diet. So again, this is a kind of way of thinking about it that brings together these different causes. And then Dominic D'Agostino has argued that the mutations that are often observed in cancer are maybe secondary to mitochondrial dysfunction, because injured mitochondria produce volatile compounds called reactive oxygen species, and these ROS can damage DNA. So in this view, it may be that mitochondrial dysfunction comes first, and then that's what leads to the mutations that are often observed in cancer. So as you might suspect, this metabolic theory of cancer is controversial in mainstream cancer paradigm, but there's already promising initial evidence to support it, and most even traditional cancer specialists concede that this metabolic theory has merit, and there's it may be a piece of the puzzle. I would say that the dominant paradigm idea right now is that metabolic dysfunction is likely one of the pieces of the puzzle, but that cancer is multifactorial and probably does involve genetic mutations that may be independent of metabolic dysfunction, and that there are other causes that may not be directly related to metabolic dysfunction. So I'm certainly not an expert in cancer, and please keep that in mind when I say this, but I do tend to agree, just my overall view of most diseases from what I've been able to gather is that they are multifactorial, and I generally resist theories that seem to suggest that, one disease has one cause. I haven't, that's unusual in my experience from everything that I've seen. And I wouldn't necessarily say that Dr. Seyfried or Dominic D'Agostino are making that argument either. But I think what they bring to this is a fresh perspective that in many ways, if it's true, it can be more empowering for people that are dealing with cancer or the risk of cancer, because it offers a lever for intervention and treatment above and beyond just the idea that, I have bad genes and there's not really anything I can do about it. Of course, we know that genes alone are not responsible for cancer, because we share many of the same genes as our hunter-gatherer ancestors, and even just the same genes as our ancestors several generations ago, and yet the rate of cancer keeps going up. It's expected to overtake cardiovascular disease as the number one cause of death in the US fairly soon, and so that can't be explained by genes alone. Getting back to the ketogenic diet, which was Kelsey's original question, both ketogenic diet and fasting restrict the availability of glucose to tumor cells. When you eat a ketogenic diet, you're dramatically limiting the amount of carbohydrate and thus the amount of glucose that comes into your body. And so from this metabolic theory of cancer, that would be why a ketogenic diet and fasting, of course, which limits not only carbohydrate, but everything else, and fasting produces ketones. This is why these two approaches would help with cancer if this theory is correct. Because when our energy metabolism shifts to fat or ketones away from glucose, cancer cells cannot utilize ketones, but our healthy cells can. So it's one of the main goals with cancer treatment, as I'm sure you know, is how do we address the cancer cells without also killing the healthy cells? And that's really the Shangri-La when it comes to cancer treatment, and ketogenic diet is really interesting from that perspective because it offers a possibility of doing that. It's a change that shift in metabolism from glucose to fat means that the cancer cells won't thrive, but the healthy cells can thrive. So let's talk a little bit about the research that exists so far on ketogenic diet and cancer. It's pretty thin overall. But what does exist, I would say, is already promising. So there's a decent amount on ketogenic diet in animals, certainly more than humans. For example, a pretty large number of animal studies have shown that a ketogenic diet can reduce tumor growth and improve survival rates. There was one 22-day study in mice that looked at the differences between the ketogenic diet and other diets. That study found that a ketogenic diet reduced tumor growth by up to 65% and nearly doubled survival time in some cases. There was another study in mice that tested a ketogenic diet with or without hyperbaric oxygen therapy, and compared to the standard diet, ketogenic diet increased survival time by 56%, and that number increased to 78% when it was combined with hyperbaric oxygen. There's less research, as I mentioned before, in humans, but the little that does exist, I think, is promising and should lead us to doing more. One study monitored tumor growth in response to a high carb versus a ketogenic diet in 27 patients with cancer of the digestive tract. Tumor growth increased by 32.2% in patients who received a high carb diet, but actually decreased by 24.3% in the patients on the ketogenic diet. However, in this study, the difference was not statistically significant. So, that's a whole nother discussion about statistical significance that I don't want to go into here, but that's one potential reason to take that study with a grain of salt. In another study, 3 out of 5 patients on a ketogenic diet combined with radiation or chemo experienced complete remission. Interestingly, the other 2 participants found that the disease progressed after they stopped the ketogenic diet. So definitely much more study is needed here, but because of our increased understanding of the metabolic aspects of cancer and some of the research that does exist and some other lines of evidence that support the metabolic theory, which I'm going to mention in a second, I'm optimistic about what we can learn here. So what are those lines of evidence? Well, there are drugs which lower insulin and glucose like metformin. It's a commonly used drug in diabetes that have shown promising results in cancer treatment. And this is not fringe stuff here. Metformin is being studied. There's an article about it for cancer treatment on the NIH Cancer Institute website and on MD Anderson website, which are 2 prominent mainstream cancer treatment organizations. And there are several studies to support that as well. Then there are some more experimental drugs that restrict the availability of glucose via inhibition of glycolysis and other processes. So one of those drugs is called 2DG, and that's shown quite a bit of promise, though there's not a lot of research on it yet. And then there's an older drug named DCA, which also limits the availability of glucose, and that's shown some promise, although it has known toxicity and side effects and may not be a good choice for that reason. Anecdotally, I've spoken with some cancer researchers who claim to be virtually curing cancer in animals using a combination of ketogenic diet and PI3K or mTOR inhibitors like rapamycin, but these data are unpublished. So again, we need to be cautious about accepting these claims until they've gone through the legitimate scientific channels and people have had a chance to review this research. There's some treatment centers like Care Clinic in the UK and Chemothermia in Istanbul that are using ketogenic diet and fasting along with glucose inhibitors and conventional treatment like chemo that claim to be getting good results. But I don't know much about these cancer centers above and beyond what I just told you. Note that keto only seems to work with the glycolytic, faster growing cancers like breast cancer, but not as much with slower growing cancers like prostate cancer. So in summary, I think the metabolic theory on cancer is really interesting, and there's already some good evidence to support it. Clearly, we need more research, and whether or not this research will get done is the big question, because as we know, 2/3 of medical research is sponsored by pharmaceutical companies. It can be difficult for researchers like Dominic D'Agostino to get funding to do this kind of research because nobody can patent a ketogenic diet and fasting, and there's not as much money as there would be in a kind of miracle drug that targets gene therapy and things like that. So that's one of the reasons why there isn't as much research as there might be otherwise. If I was diagnosed with cancer, one of my relatives or friends were diagnosed, I would certainly put ketogenic diet and fasting at the top of the list of potential treatments to investigate, because I see high potential for benefit and very little downside. And you can't say that about many cancer therapies. As we talked about earlier, the goal with cancer treatment is to find something that inhibits the growth of cancer cells but doesn't damage healthy cells. And again, there just aren't that many therapies out there that do that. I want to be very clear, though, that I don't believe claims that are made on some websites that ketogenic diet beats chemotherapy for all cancer treatment. There's simply no research to support that. I don't know where those websites are getting that idea. There's a lot of snake oil when it comes to cancer treatment out there. And it's a really vulnerable population. Someone who's diagnosed with cancer, particularly a late stage cancer that might be terminal, understandably will often feel pretty desperate and might not have the capacity at that moment in time to go through the proper vetting process to make sure that some of the more alternative therapies that are suggested are legitimate. And so you see a lot of wacky stuff recommended for cancer treatment. Now, I don't at all think that metabolic theory of cancer is wacky. There's plenty of both mechanistic and animal and even some human evidence to support it. But I would, personally don't believe the extreme claim that like a keto diet will beat chemo for all cancers. I just don't think there's research to support that. I also want to be clear that I'm not making any specific recommendation here for treatment of cancer using ketogenic diet or anything else. As I've argued, earlier in the podcast, I think cancer is a complex, multifactorial disease, and the etiology and pathology will vary from individual to individual, and treatment decisions should be made with the support of an oncologist and other doctors on the care team. So, please don't take anything that I've said in this podcast as a recommendation for your particular situation or somebody in your life that's struggling with cancer. All of that said, really promising, interesting info here. And we know that ketogenic diet can be therapeutic in many other situations. And there's not really much downside to ketogenic diet and fasting if they're done under supervision. Both can have a lot of beneficial effects in terms of upregulating autophagy, cellular repair process, possibly stem cell regeneration in the case of fasting for both of those. Ketosis has neurological benefits and many other potentially positive effects when it's done in the right circumstances. So I don't see any downside at all in continuing to explore these therapies for cancer treatment. Okay, thanks again, Kelsey, for sending that question. It's a really fascinating topic. And everybody else, please do keep sending your questions to kriskresser.com/podcast question. And I'll see you next time.
That's the end of this episode of Revolution Health Radio. If you appreciate the show and want to help me create a healthier and happier world, please head over to iTunes and leave us a review. They really do make a difference. If you'd like to ask a question for me to answer on a future episode, you can do that at kriskresser.com/podcast question. You can also leave a suggestion for someone you'd like me to interview there. If you're on social media, you can follow me at twitter.com/kriskresser or facebook.com/kriskresser L.A.C. I post a lot of articles and research that I do throughout the week there that never makes it to the blog or podcast, so it's a great way to stay abreast of the latest developments. Thanks so much for listening. Talk to you next time.